Welcome viewers. In this video we'll see the construction and working principle of Autotransformer. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic Autotransformer. We'll see the construction and working principle. So the Autotransformer is a special type of transformer having only one winding, such that part of the winding is common to primary as well as secondary. Normally in two winding transformer we have primary winding and secondary winding. Two different windings are available. But in auto transformer we have only one winding. The part will be used as primary and part will be used as a secondary winding. So it is working on conduction as well as induction. There is a mutual inductance principle as well as the conduction principle. Electrical isolation is not necessary. Only one winding is available. Power is transferred both inductively as well as conductively. It is based on the inductive and conduction. Now we'll see the construction of this auto transformer. A single winding is winded on a laminated magnetic core. So only one winding is available. Single winding used as primary and secondary. The part is used as primary and part will be used as secondary. Part of the winding is common to primary and secondary, right? Either the entire winding may be used as primary or secondary. The part will be used as either primary or secondary. So the commonly available windings are there that will be used for both primary and secondary. Voltage can be step up or step down using the auto transformer. The step up and step down is possible in the auto transformer. Normally it is used as a voltage regulator in here while starting the motors. Now we'll go to the step down transformer. The step down transformer, with that we have only one winding is available. We already discussed in the auto transformer having only one winding. This entire winding is used as a primary. The primary P1 and P2 refers the primary winding. The entire winding is used as a primary winding. Here we have the secondary winding, that is part of the winding. The part of the winding used as the secondary, S1 and S2. So this portion is commonly used for both primary as well as secondary. So in the step down transformer, entire winding used as a primary winding, part of the winding used as the secondary winding. It is given as the name A, this term is A, this portion is C and this one is B. So AB is the primary winding, then BC is the secondary winding. It is given here, AB equal to N1 turns. The entire winding is AB, N1 turn, that is used as a primary. This BC is the N2 turns, that is as a secondary winding. So N2 is less than N1. The number of turns in secondary is less than the primary winding. So automatically it is a step down transformer. So this is the voltage applied. V1 is the voltage applied to the winding. So the entire voltage is applied to the primary winding. So the part of the voltage only used as a secondary winding. So automatically V2 is less than V1. Now you see the current direction. The current flowing through the primary winding is taken as I1. This is the current entering and current leaving. Here this I2 is the current flowing through the secondary winding. So load is connected. So at this portion, here the I1 is available. So at this portion, the common portion between primary secondary, both I1 and I2 is flowing. So the difference in current, I2 minus I1 is flowing through the part of the portion, that is in the part of the portion BC, the current flowing is I2 minus I1. In this portion AC only I1 is flowing, but here both I1 and I2 is available. So the difference in current I2 minus I1 is flowing in the section BC. So in the step down auto transformer, the entire winding is act as primary, while part of the winding is common to primary and secondary. So N2 is less than N1, automatically V2 is less than V1, right? So the secondary voltage is lesser, so that it is called as a step down transformer. Now we'll go to the step up transformer. So in step up auto transformer, here also we have only one winding, but the entire winding is used as a secondary winding. The earlier step down transformer, the entire winding used as a primary winding. Now the entire winding is used as secondary winding, S1 and S2. Part of the winding used as the primary winding. So that it is a step up transformer, right? So this termed as it is A, B and C. So AB, the entire winding is N2 turns, that is used as a secondary winding. The part of the winding BC is common to primary and secondary, that is N1 turns. So N1 is, this N2 is greater than N1. So automatically V2 is greater than V1. So that is a step up transformer, right? So the entire winding AB used as a secondary winding, part of the winding BC used as a primary winding, that is common to primary and secondary. V1 is the voltage applied to the primary winding V1. V2 is the voltage available across the secondary winding, load winding. Now see the current. So this I2 is flowing in the secondary winding, I2. The entire I2 is the flowing in the secondary winding. So this portion I2 will be flowing. In this common portion, the current flowing in the primary is I1, secondary is I2, primary is I1. So this portion is common. So both I1 and I2 is flowing in this portion. So the I2 is flowing from downward to upwards, I1 is flowing from upward to downward. So the difference in current I1 minus I2 is flowing in the common section BC. So this BC is common to primary and secondary. So the difference in current I1 and I2 is flowing in the common section BC, right? I1 is flowing in primary, I2 is flowing in secondary. In the common portion, I1 minus I2 is flowing. Now we'll see the description. In step up auto transformer, the entire winding acts as a secondary, while part of the winding is common to primary and secondary. So N2 is greater than N1, automatically V2 is greater than V1. So that is a step up transformer. Now we'll see the advantages. So the copper requirement is lesser in this auto transformer. Only one winding is available, so automatically the copper requirement is lesser. Efficiency is comparatively higher, right? There is no drop, the efficiency will be comparatively higher. Size and cost is comparatively less because only one winding is available. Resistance and leakage reactance is comparatively less. All these things are because of only one winding. Because of only one winding, copper requirement is less, efficiency is more, cost is less, resistance and leakage reactance also very less. Copper loss. So copper is lesser, so copper loss also automatically lesser. Voltage regulation is higher than the two winding transformer. Voltage regulation. Smooth and continuous variation of the voltage is possible. VA rating is more, right? So these are all the advantages. Some limitations are available. The low impedance is there, the entire thing, the low impedance is there. So hence high short current for an short circuit on secondary winding, right? So the low impedance is very low. If we go for a short circuit, so AC test or short circuit, the more amount of short circuit current will flowing through the secondary winding. If a part of winding is common to primary and secondary, full load primary voltage appear across the secondary, right? Because we have only one winding, the part will be common, so that the full load voltage is applied across the secondary, resulting in high voltage on secondary, so the danger of accidents. So the entire voltage is applied across the secondary winding. So there is a possibility of the high voltage will appear across the secondary winding. So there is no electrical separation between primary and secondary, which is risky in case of high voltage level. So there is no isolation, only one winding is available. So there may be a possibility of high voltage will appear either in primary or secondary side. Economical only when the voltage ratio is less than 2. We cannot use it for more than 2. So the voltage ratio less than 2, this auto transformer is effective. More than that we cannot use for this, efficiency will be very less. We will see the applications of this auto transformer. So it is a starter for safety starting of induction motor and synchronous motor. So it is auto transformer, we can slowly, by adjusting the voltage is slowly applied to the motor. So it is act as a starter, right? The voltage given to the motor is slowly increased, so that speed of the motor also slowly increase. So it is act as a starter. As a booster to give small boost to the distribution cable to compensate the voltage drop. So, in the distribution level, when the distance increases, the voltage will keep on decreases due to the losses. So, this auto transformer can be used to boost up the voltage. So, it is act as a booster. As a furnace transformer to supply power to the furnace at the required supply voltage. For a furnace transformer, it is used. This auto transformer is used to give the required supply voltage. For interconnecting the system which are roughly operating at the same voltage level. Suppose if the n number of systems are there interconnected, mean the voltage level is different, by using the auto transformer we can give the same voltage level for all the system. The system having different voltage level, mean by using the auto transformer we adjust to the common level, we adjust to the one particular value. Used to vary the voltage to the load smoothly from 0 to rated voltage. So, by using the auto transformer smoothly we can vary the voltage starting from 0 to the rated voltage. So, in this video we discuss about the construction and operation of a auto transformer, step up as well as step down, then applications, limitation and advantages. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the equation for copper saving in auto transformer. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic, equation of copper saving in auto transformer. We know that there are two type of transformer, two winding transformer and auto transformer. With it, this auto transformer, the copper is saved. We are going to frame the equation for copper saving, because in auto transformer we are using only one winding, that is for both primary as well as secondary. So, automatically we will get the copper saved. The amount of copper used is lesser. For that we are going to frame the equation. So, for any winding the cross section is directly proportional to current. The cross sectional area or the area is decided, the size of the cable is decided by the current I. Similarly, the length of winding is directly proportional to number of turns N, right. So, the current will decide the size of the wire, the length of the wire is decided by number of turns. So, totally the weight of the copper is directly proportional to N into I. So, these two are the primary factor deciding the weight of the copper. So, I refer the area, N refer the length. So, totally the weight of the copper is proportional to N into I. Now, we will compare the two winding transformer as well as the auto transformer. So, this is the two winding transformer, that is primary winding and secondary winding. We have primary winding and secondary winding. So, the N1 is the number of turns available in primary winding, N2 number of turns available in the secondary winding. I1 current in the primary winding, I2 current in the secondary winding. V1 is the voltage applied to primary winding, V2 is the voltage available in the load terminal of the secondary winding. Now, we will go to the auto transformer. In auto transformer we have only one winding is available. It is given as the name A, B and C. So, the entire AB is used as a primary winding. Here we are compare the step down transformer. So, the entire winding used as a primary winding. The part of the winding used as a secondary winding, that is BC. Only BC is used as a secondary winding. Now, we will compare with the current. The current in the primary winding is I1. Current in the secondary winding is I2. But this is the common portion. Here both primary current and secondary current will flow. So, the difference between this primary and secondary, I2 minus I1 is flowing through the section BC. Right. So, I1 is primary current, I2 is the secondary current. In a common area BC, I2 minus I1 current is flowing. Now, we will see this number of turns AB. AB is nothing but primary winding. Number of turns is N1. BC is the secondary winding, is N2. Suppose number of turns in the section AC mean N1 minus N2. N1 refers the primary winding, entire winding. N2 refers the section of common section of winding BC. For the case suppose if we need the winding in the section AC mean the difference between these two, N1 minus N2. Now, our aim is we need to analyze the copper required for the two winding transformer as well as the autotransformer. Let us consider WTW. TW means two winding. WTW is the weight of the copper in two winding transformer. Let us assume that WTW. WAT is the total weight of copper in autotransformer. So now we are going to compare these two. What is the weight of two winding transformer? What is the weight of autotransformer? First we will see the two winding transformer. Weight of copper in primary winding is N1 into I1. We already discussed the weight is depends upon the number of turns and current. So primary winding means it is N1 and I1. In case of secondary winding means N2 I2. So the total copper required is N1 I1 plus N2 I2. So the copper requirement in the two winding transformer is N1 I1 plus N2 I2. Suppose in case of the autotransformer, the weight of copper in the section AC. Section AC is directly proportional to N1 minus N2 into I1, because in AC AC is the section in the difference between this N1 is the primary, N2 is the secondary. AC means the difference between these two is into I1, because I1 is flowing only in the section AC. Similarly, weight of the copper section BC is N2. The secondary winding, the number of turns is N2, but because of common area, the current flowing is I2 minus I1. Right? So we need to see AC and BC. AB is the total weight of the copper. Here we are assume that this is the primary winding and this is the secondary winding. So in the primary winding, number of N1 is the number of turns, but in the section AC, N1 minus N2. BC acts as a secondary winding, so N2 into I2 minus I1. Right? So totally we are considering A to C and C to B. So the entire winding we consider. So the total weight of the copper is N1 minus N2 into I1 plus N2 into I2 minus I1. Right? I will refer the diagram so that. So this one we consider AC. AC means N1 minus N2. The current flowing is I1. Similarly, the second section BC. BC number of turns is I2, N2. But the current flowing is I2 minus I1. So we consider AC and BC. Now we will compare the weight of two winding transformer and autotransformer. So by taking the ratio, in order to compare, we are taking the ratio of two winding. Two weights, WTW divided by WAT, that is weight of the two winding transformer divided by autotransformer. So N1 I1 plus N2 I2 divided by N1 minus N2 into I1 plus N2 into I2 minus I1. Now we will multiply inside, so that N1 I1 plus N2 I2 divided by N1 into I1, N2 into I1 minus plus N2 into I2 minus N2 into I1. Right? So what we have here, we have N1 I1, N2 I2. This N2 I1 available 2 times, minus negative minus N2 I1 available 2 times. So that minus 2 N2 I1. So after simplification we got this value. So by using the transformation ratio, we know the transformation ratio K equal to N2 by N1 or I1 by I2. In case of current it is reverse, N2 by N1, V2 by V1, current is I1 by I2. So from this we can write N2 equal to, cross multiply this, N2 equal to K into N1. Similarly, in this I1 equal to K into I2. So this I2 equal to I1 by K. Right? So we are getting the value of N2 and I2 from this equation. Right? So this N1, K and N1 is multiplied, so that N2 equal to K into N1. Right? So this I2 is brought in the numerator, K is brought in the denominator, so that I2 equal to I1 by K. Now we will substitute these two values, N2 and I2, in the above equation. So WTW divided by WAT equal to N1 I1 plus N2 is nothing but K into I1. N2 is the K into I1. Similarly, I2 is I1 by K, that is substituted, divided by N1 I1 plus K N1 into this I1 by K. I2 is substituted, I1 by K, minus this, again it is substituted, k N1 into I1. Now we can simplify this. This k got cancelled. Here also cancel, here also cancel. So finally what we have, N1 I1 plus N1 I1 divided by N1 I1 plus N1 I1 minus 2 times of k N1 I1. So all terms are available as N1 I1, both in numerator as well as the denominator. So we can take this N1 I1 common. So that here 1 plus 1 divided by, here also we can take common. So 1 plus 1 minus 2k. So this N1 I1 got cancelled. So 1 plus 1 2 divided by 1 plus 1 2 minus 2k, right. So these 2 also commonly available, everywhere 2 is available, so that we can write WTW divided by WAT equal to 1 divided by 1 minus k, right. This is the finally what we got. The weight of the 2 winding transformer divided by weight of the auto transformer is 1 divided by 1 minus k. So by cross multiplying we can get WAT equal to 1 minus k into WTW. Weight of auto transformer equal to 1 minus k into weight of 2 winding transformer. Now we will multiply inside. So WAT equal to WTW minus k into WTW, right. So k into WTW, this term is brought in the left hand side and this term is brought in the right hand side. So that k WTW equal to WTW minus WAT. So this is the difference between this 2 winding transformer and auto transformer. So we can write WTW minus WAT, that is the difference in weight between the 2 winding transformer and auto transformer is k times of WTW, right. So that is available as k times. The k is nothing but here is a transformation ratio. So it is given as saving of copper, that is the weight of difference between primary and secondary winding is k times of weight of 2 winding transformer. So this is applicable for step down transformer, right. So what is the meaning? The saving in copper is k times of total weight of copper in the 2 winding transformer. So this is k times. In case of step up transformer, it is 1 by k times of WTW. Previously k times, here 1 by k times, right. So that by referring the transformation ratio, V2 by V1 equal to N2 by N1 equal to I1 by I2. So in this video we discuss about the equation of copper saving for a auto transformer. We will compare with the 2 winding transformer. We got the expression, that is it is the k times of copper saving is k times of 2 winding transformer in for a step down transformer. For step up transformer, 1 divided by k times. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.